everyone, I am Sunanta from SNS College of Technology, Department of Mathematics. Now in the lecture video series of diagonalization, we are going to see a design thinking based approach to a topic, diagonalization. So as we all know that design thinking is a 5-stage approach process in which first one we empathize, second we define, third we ideate, fourth we prototype, and finally we test our method. So here first let us empathize the part. So empathizing, that is understanding the student's perspective about the diagonalization. So these are the three common things which usually first year students see. First one is common confusion. So they see matrices as abstract. That is, what even is transformation? First of all, when they are entering into a first year, they don't know about what is transformation and all. Till 12th standard, they won't study about transformation processes. They just only used to study matrix, rank of the matrix, and calculation of the x and y values. So they don't know about transformation. Next, why this diagonalization is important? That is the second one. Then is lost in steps. That is, they don't know about what is eigenvalue, eigenvectors and all, so they get confused over there. Next, let us define our diagonalization. So the thing is the core problem and how we can approach them. So why diagonalization is important and why is it so hard to grasp for first year students? So they lack intuitive connection to real world problems. So till 12th standard they are only studying what is given in the book and they will write. So they don't know about the real world applications and the problems. So that is first. Next, overwhelm for new terminologies. So they will be introduced into new technical terms like eigenvalues, eigenvectors, and quadratic forms, canonical forms, and all. So they stuck there. Next is difficulty visualizing the matrix transformation. So they don't have the idea or how to visualize the matrix transformations. That is how it is transformed from one form to another form. For example, from quadratic form into a canonical form. Next is our learning goals. So how can we make diagonalization simpler, more intuitive, and show its practical values to students? So first is we can connect concepts to relatable analogies. So first let us connect this with real life application. Next, let us break down the complex steps. So that is we can explain each and every step clearly to make the students understand the concept clearly. Next, highlight the practical applications. So when we highlight the applications of each and every topic, students will be able to grasp that easily. Next is ideate. So ideate is, what is the ideate? Why we have to use this diagonalization? Where it is applied practically. That is what we take under ideate thing. The GPS analogy. So think of diagonalization as finding the straight path or natural directions for a transformation. Next is geometric insights. So visualize how certain vectors only scale, not change direction under a transformation. Next is problem decomposition. Breaking down a complex matrix into a simple diagonal component for easier calculation. So when we have a matrix with all the entries, it will be very difficult to solve. So when we convert that matrix into a diagonal form, that is only elements will be present in the diagonal elements, will make the students solve the matrix easier. Next is ideate. So here in the ideate, we'll consider the simple matrix and make the students to solve that using a brainstorming method which could help them to solve more problems. Next is prototyping. So prototype the diagonalization modules. So first one is finding eigenvalue. So when we are given with a 2 by 2 matrix or 3 by 3 matrix, first let us frame the characteristic equation by determinant of a minus lambda I equal to 0. So first we are going to find a minus lambda I. After that, taking the determinant of that will give the quadratic equation of order 2 for 2 by 2 matrix and order 3 for 3 by 3 matrix. Next, we are going to find the eigen value of that. So the lambda value gives the eigenvalues. If we have 2 by 2 matrix, we'll have 2 eigenvalues. When we have 3 by 3 matrix, we will have 3 eigenvalues. Next is finding eigenvectors. So using a minus lambda I into v, that is when we apply lambda value in the equation, we will get the three set of, when we have two eigenvalues, we get two set of eigenvectors. When we have three eigenvalues, we will get a three set of eigenvectors. Next is to construct P and D. This P and D are nothing but D is a diagonalized matrix and P is a matrix which will be formed from the eigenvectors. Next is diagonalization. So A is equal to PD. P inverse is the diagonalized matrix. Next is prototyping, visualizing the transformation. This is how the complex transformation and the simplified transformation looks like. So here the first diagram is about matrix A can stretch, shear and rotate vectors in arbitrary direction, making their long-term behavior difficult to predict. Next is, in the simplified method, diagonalization allow us to view the same transformation in a special coordinate system where it only stretches or shrinks along the axis. Next is test part. So when check your understanding, first we can explain. Can you these are the type of questions we can ask to students. Can you explain in your own words why eigenvalue represent geometrically? Why we can, the next one will be 2 by 2 matrix is diagonalizable. Next is real world connection questions can be asked with students. Next, these are the some few examples of matrices which can be used to solve. So we can give hints also. Next is takeaway. So empathize, understanding student struggles help tailor explanation. Next, ideate. So we have to give the proper ideate of the given question. Next is prototyping, simplifying each and every step clearly could make the students understand the concept. Next, taking quizzes, test part, giving quizzes and doing brainstorming activities could make the students understand the topic clearly. Thank you.